At sunrise, California's entire coastline had jumped 6 feet skyward. No tremors, no warning, just every sensor, from NASA to NOAA, confirming the land itself was now higher than it should be. 40 million lives hang on the answer. What force could move an entire state overnight without leaving a trace? Science has no precedent, and the search for answers begins now. Inside NASA's Jet Propulsion Laboratory, the first alert came from a technician reviewing overnight GPS logs. The numbers did not drift, they leapt. Every reference station from Crescent City to San Diego reported an identical 6-foot jump, stamped with the same timestamp. The technician pulled the backup logs, expecting a glitch. The backup matched, line for line. In the control room, staff gathered around monitors, usually tuned to fractions of a millimeter in annual drift. California's crust, tracked for decades, had always crept at a glacial pace, 3, maybe 4 millimeters a year, sometimes less. Engineers could map the slow rise and fall of the land with such precision that even seasonal groundwater changes showed up in the data. But nothing in the archives, no earthquake, no landslide, no volcanic event, had ever produced a uniform statewide surge like this. JPL's raw logs, cross-checked against years of slow, steady movement, now showed a vertical wall. The data was clear. The ground itself had shifted in a single bound, defying every known pattern. For the scientists who had built their careers on the reliability of these measurements, the event was both a professional shock and a personal jolt. The question was not just how it happened, but whether the very rules of the Earth's crust had changed overnight. As the lab scrambled to verify, the scale of the anomaly loomed larger with every minute. The search for a physical cause had begun, but the baseline, the slow, predictable heartbeat of California's coast, was gone. USGS seismic arrays, tuned to detect even the faintest tremors, recorded nothing. Not a single spike broke the flat lines of their overnight logs. The Southern California Seismic Network, with sensors spaced every few miles from the Mendocino coast to the Mexican border, showed the same unbroken calm. These instruments routinely pick up quarry blasts, freight trains, and storms rolling in from the Pacific. Yet during the exact window when the coastline vaulted upward, the data was silent. No microquakes, no slow slip, not even a distant rumble. Caltech's waveform archives, reviewed frame by frame, revealed no hint of ground motion. IRIS stations, sensitive enough to catch earthquakes on the far side of the globe, remained undisturbed. The USGS issued a rare, unequivocal statement. No seismic energy detected. No earthquake occurred. For the team of analysts in Menlo Park, this was not just unexpected, it was unnerving. Every known mechanism for rapid regional uplift leaves a seismic fingerprint. The 1964 Alaska event, the 2011 Tohoku earthquake, even minor offshore faults all broadcast their movements through the ground. Here, the Earth had shifted in silence. Protocols demanded a full forensic audit. Instrument logs were pulled for clock errors, firmware glitches, and maintenance gaps. Each station's calibration history was checked against the event timeline. Redundant networks, including marine geophones and deep borehole sensors, confirmed the void. With the earthquake hypothesis erased, the investigation turned inward. If the world's most advanced seismic network missed nothing, what force could lift a coastline without a sound? Raw data from every RINEX GPS station was pulled. No summaries, no averages, just the original RINEX logs. Quality assurance engineers at the NASA Jet Propulsion Laboratory and the USGS rebuilt the entire vertical motion record from scratch, line by line, using separate processing teams and different software stacks. Each group worked independently. Some relied on SNAP, others on gamma or ESEE, all with their own atmospheric corrections and reference frames. Every output, no matter the method or baseline, showed the same 6-foot vertical leap. The audit extended to firmware logs, antenna swaps, and clock resets, searching for any hint of a processing artifact. Nothing explained the jump. To rule out a satellite illusion, engineers turned to radar. Sentinel-1 raw bursts, together with ALOS data, were reprocessed by external academic teams. The INSAR maps, built from unfocused SAR bursts and rigorously corrected for atmospheric noise and terrain, matched the GPS results exactly. No phase unwrapping errors, no reference frame drift. The vertical wall of uplift held firm in every test. Meanwhile, the National Oceanic and Atmospheric Administration tide gauge records offered a completely different line of evidence. At harbors from Crescent City to San Diego, water levels dropped by exactly 6 feet at the same instant the land rose. These gauges, anchored in concrete and cross-checked against collocated GPS, are immune to satellite or reference frame errors. Their measurements, sampled every 6 minutes, showed the ocean falling away from the shore in lockstep with the land's ascent. By the end of the audit, every independent system, ground-based GPS, satellite radar, and physical tide markers, agreed. The uplift was real, not a mirage of processing or software. With the anomaly locked in, the debate over what could cause such a silent, sweeping event was about to begin. Specialists from every agency gathered for an emergency call, each with their own theory and none with a solution. The first explanations leaned on precedent: earthquake rupture, volcanic intrusion, even a massive landslide offshore. But every candidate mechanism hit a wall. Earthquakes of this scale always leave seismic fingerprints. Volcanic bulging brings tremor and heat. Landslides, even the largest, only nudge the land by inches or feet over years, and always in isolated stretches. The Portuguese Bend landslide just south of Los Angeles is often cited as California's textbook case for uplift. There, slow toe movement has lifted ground by a few millimeters each year since the 1950s. Nowhere, not even in the most active landslide zones, has uplift ever approached 6 feet overnight or spanned 400 miles. Suggestions of aquifer rebound or sudden gas release faltered under scrutiny. The energy required to push up the entire coastline would dwarf any known reservoir. As each hypothesis collapsed, frustration mounted. The familiar rules of geology, steady, local, incremental, could not explain what every instrument now recorded as fact. Cargo ships circled offshore as the ports of Los Angeles and Long Beach stood silent. With berths stranded 6 feet above the waterline, cranes and containers sat idle. The daily flow of $1.4 billion in goods ground to a halt, rippling through supply chains from Asia to the Midwest. Port managers, caught off guard, scrambled to reroute vessels and field calls from anxious exporters. Emergency meetings stretched into the night, but no workaround could lower the docks to meet the sea. Along the coast, marine biologists confronted a different disaster. Tide pools left high and dry, baked in the sun, their usual tides gone. Mussels, sea stars, and anemones died in place, unable to retreat with the water. Rescue teams rushed to document the loss, but the scale outpaced any response. As news broke, GeoStride Analytics, an upstart satellite firm, challenged the official narrative. Their spokesperson accused JPL and USGS of minimizing the numbers, fueling a media storm. Accusations flew on live broadcasts: cover-up, incompetence, even sabotage. The scientific mystery had become a public crisis, with economic and ecological fallout on full display. A federal emergency review team assembled before dawn, pulling in senior officials from USGS, NASA, and the Department of Defense. Within hours, access to raw sensor feeds and internal logs was restricted to classified channels. Requests for high-resolution satellite imagery were routed to the National Reconnaissance Office, activating protocols normally reserved for national security threats. Analysts at the National Geospatial-Intelligence Agency began cross-referencing civilian and military satellite passes, searching for any visual clue, fresh fault scarps, surface ruptures, or signs of sabotage. The review process, shielded from public view, brought together experts who had never before shared a table. Every data set was reprocessed in isolation, then compared behind closed doors. Meanwhile, live ground sensors kept reporting a slow, persistent upward drift, centimeters more, hour by hour. The coastline, already 6 feet higher, showed no sign of settling. For the first time, the investigation moved beyond scientific anomaly into the realm of national security. Uncertainty grew with each new reading as the question shifted from what happened to what might still be unfolding beneath millions of feet. Today, millions rely on sensors to define where safe ground ends and danger begins. When the Earth defies our measurements, certainty vanishes. As science scrambles for answers, one truth remains. Nature still writes the rules, and it never warns before rewriting them.